One approach to evaluating limits at infinity is to remember our horizontal asymptote rules. Horizontal asymptote rules said that if the greater power was in the numerator, then there wasn't a horizontal asymptote, which would indicate that there's not a limit as x approaches infinity. If the power in the numerator was equal to the highest power in the denominator, then the horizontal asymptote was the ratio of the leading coefficients. So that would also be what our limit is as x approaches infinity. And then the final rule was if the greater power was in the denominator, then the limit was 0. So we're going to use those horizontal asymptote rules to evaluate these limits. The first one says the limit as x approaches infinity of 8x plus 6 divided by 3x minus 1. Notice that the greatest power in the numerator is 1 and the greatest power in the denominator is 1. So the horizontal asymptote would be the ratio of the leading coefficients, and the horizontal asymptote is the same thing as the value that the limit, the x is getting closer and closer to becoming as you approach infinity. So the answer to this first example is 8/3. On the next example, notice that the greater power is in the denominator, so the horizontal asymptote would be equal to 0, which means the limit as x approaches infinity would be 0. On the third example, the limit as x approaches infinity of 3x squared plus 2 divided by 4x minus 3. The greater power is in the numerator, which means there is not a horizontal asymptote, so there is no limit. And in our last example, the limit as x approaches infinity of 5x squared minus 4x cubed over 3x squared plus 2x minus 1. Again, notice that the greater power is in the numerator. There's no horizontal asymptote, so there is no limit as x approaches infinity.